Hey guys, we're going to go ahead and get started with reviewing the homework. It was a practice quiz that you had, and we're just going to go through each problem individually. If you feel like that problem was too easy and you're sure you got it right, feel free to fast forward through the video, move to the next problem, or rewatch one, or pause it if you need extra time and more thinking on that particular problem. So let's just go through each one. All right, so we'll start with the front page, which was intended to be those sort of easier, plain old integrals. And we'll start with the integral of 5 cosine of x. And of course we know that if we have a constant out front like that, we can pull it out and put it in front of the integral sign. That's just one of our properties of integrals that we learned. And of course we've memorized the fact that the integral of cosine is sine. So we have 5 sine of x plus c. Good. Next one. This one was a little bit tricky because we have these two functions being multiplied together. You have 4x squared plus 6x minus 2. And if you try to do u substitution or something, you're going to run into some trouble. And the easiest way to do this actually is to just distribute that x before you integrate. So we'll throw that x inside all of them. That makes this 4x cubed. That makes this 6x squared. And that makes this minus 2x. And then we integrate like we normally do. 4x cubed, well, that's just x to the 4th. For this one, we get x cubed, and we divide by 3, so we get 2x cubed. And for this guy, we get x squared and divide by 2, so it's just plain old x squared. So that's the answer, x to the 4th plus 2x cubed minus x squared plus c. Next, I've already gone ahead and done the next step of converting the cube root of x in the denominator to x to the negative 1/3, negative because it's in the bottom, and 1/3 because it's a cube root. And now all we have to do is integrate like we normally do, but in order to do that, we need to know how to add fractions. So what's negative 1/3 plus 1? Well, there are 3/3 in 1, so negative 1/3 plus 3/3 is 2/3. So that gives me x to the 2/3, and then we multiply by the reciprocal, which is the same as dividing, and that gives me 3/2 out front. 3/2 times 6 is 18/2, or 9, so I have 9x to the 2/3, or 9x squared cube rooted, because the 2 becomes inside as the exponent, and the 3 on the bottom here becomes the cube root. Don't forget about your plus c. Last one, again, I've already gone ahead and rewritten this. It was 7 over x cubed, which is the same as 7x to the negative 3. We add 1 to negative 3, and we get negative 2, and we divide by that negative 2 like so. And that leaves me with x to the negative 2 here, which I can then just put in the bottom as x squared, like that. Don't forget your negative. So we have 7 over 2x squared, negative 7 over 2x squared plus c. All right, what's next? A little bit of a longer one. And I'm going to go ahead and just remind ourselves of another one of our integral properties. Remember that if things are being added inside the integral, we can integrate them separately. So I could rewrite this as an integral of each of those individual terms. If the individual terms were being multiplied or divided, then this would not be the case. But in the case of addition or subtraction, we can integrate the terms individually. So for the first one, if I wanted to, I could pull that, rewrite it as x to the 1/2. Okay. And for the second one, I could pull that 2 out if I wanted to, if I was just feeling that. And this thing, I just want to rewrite, again, like I've shown you a few times on the AP exam, if there's a 1 here, they could just replace that 1 altogether and just put the dx right there. And you need to sort of remember that, okay, there's a 1 there. It's a constant times dx. All right, let's integrate each one. X to the 1/2, so we add 1 to 1/2. That gives me 3/2. And we multiply by the reciprocal, so 2/3, x to the 3/2. And don't forget about your 5 chilling there. Over here I've got 2x, so the integral of that is x squared. You should just sort of be able to see that at this point. And the integral of 1, or just plain old dx, is slap an x on that, 1x, or just x. And of course, don't forget about plus c. Now all we have to do is take this 5 and move it up top there. We got 10/3 times the square root of x cubed. That's just bringing the 3 from here down there, and the 2 from there into the root. Now we have x squared for that, and x just like we did before. Next problem was kind of broken because this is from my quiz from last year. Last year, one of the integrals that I made the kids memorize was the integral of ln x. So you needed the fact that the integral of ln x is x ln x minus x, which maybe if you were a stellar student you could have figured out, but that's kind of tricky. But either way, you needed this fact to complete the problem. So if you didn't get this one, that's totally fine. But now that we do know that, let's try and use it to solve the problem. We know that the integral of ln x is x ln x minus x plus c. So we can pull that 6 right out from there, and then, or leave it there even, and that gives us the integral that's 6 times x ln x minus x plus c, and then just distribute the 6 to finish that. And again, don't really worry about that one too much, because we didn't have the fact that the integral of ln x is x ln x minus x. But I do want to show the point that if I pulled this 6 out to the front, okay, it ends up getting distributed to the entire integral. So it wouldn't just be 6x ln x minus x, it'd be 6x ln x minus 6x, as this 6 is distributed across the parentheses. All right, now we're going to try a couple initial value problems. For these, not only do you have to integrate to find y, because they give you dy dx, you can then use the fact that y of 2 is 9, or in other words, when x is 2, y is 9. So let's go ahead and integrate to find y. Remember, if we have a derivative and we integrate, we get the original function. So we have dy dx. Let's integrate to get y. So we integrate this. Let's do this. Let's do it. X squared becomes x cubed, and we divide by the 3. That gives me 3x cubed. Minus 2x. Again, at this point, you should be able to just see that that's x squared. And the minus 8 becomes minus 8x as we slap an x on that. And we don't forget about our plus c's. The last step now is to plug in x equals 2 and y equals 9. And then to go about doing our math. 2 cubed is 8 times 3 is 24. Minus 4 is 20. Minus 8 times 2, which is 16, gives us 4. And then we can subtract the 4 from both sides to give us a c of 5. Now again, that's not the final answer. The final answer is the entire function. So we say y equals 3x cubed minus x squared minus 8x plus 5. Other side, same idea, just changing the function and the point that's given. We have 1 over x cubed minus x plus 3. So we integrate that to get y. And we're going to have to rewrite this one to figure out its integral. This is x to the negative 3, because we have x cubed in the denominator. That's what the negative means. And we go ahead and integrate that. So minus 3 plus 1 is negative 2, not negative 4. And we divide by that negative 2. So we get that. And of course, minus x becomes x squared, and we divide by that too, so we get minus 1/2 x squared, and we slap an x on the 3 plus c. All right, not bad. I'm going to rewrite this a little bit, put this x squared down in the bottom here, and remove its negative sign. Okay, no problem there. This negative means it belongs in the denominator. Don't forget about this negative. That's still chilling out front. Now we can use our fact that when x is 1, y is 2. You can go ahead and plug in. So y is 2, x is 1. I've replaced all the x's with 1. Okay, and now I just need to do my algebra, or my arithmetic. So 1 squared is 1. So this whole thing is negative 1/2 because of the negative sign out front. This whole thing is negative 1/2. So what happens when you take negative 1/2 and subtract 1/2 from it? You get negative 1 plus 3, because 3 times 1 is 3, is just 2. So that means that c is 0. Okay, that means that my final answer is not this whole thing. Okay, the c is 0, so I just drop it. And that means my final answer is this. All right, a couple u substitution problems, and then we're all done. And the first one, you could choose actually either sine or cosine to be u. It's your choice. I chose cosine, or sine, I guess. Du dx is cosine, and then I flip them around to put cosine in the bottom. Okay. Then what I can do is I can go ahead and replace everything. I'll take the sine and replace it with u, and the dx and replace it with this big ugly stuff. And that gives me this. Okay? And luckily for us, we notice that the cosine up here and the cosine down here are going to cancel. So you can cross those out, and you're left with the integral of 4u du, which of course is just 2u squared plus c. Then the final step is to simply replace the u with the sine to give us 2 sine squared of x plus c. Remember that sine of x squared, the whole quantity, is the same as sine squared of x. There's just another way to write it. If you had chosen to use cosine for u from the start, then that would have been fine. You just would have gotten a slightly different answer, although they are actually equivalent. It was negative 2 cosine squared of x, and it should say plus c there as well. This next problem I'm going to go through a little bit quickly because we've done this problem. We just did it with tan before. Now we have cotan, right? And we've given the fact that cosine of x over sine of x and cotan of x are the same thing. So we can replace that right like so. And you can choose, only one thing works, I think, to choose for u in this one. So maybe you screwed that up, but the first step to do is to choose sine for u. The derivative, of course, is cosine, and then I just sort of skipped the step and threw that cosine in the bottom, keeping the dx up top. I replaced the dx with this junk. I replaced the sine with u, and I'm left with this. And lucky for us, the cosines cancel out. Now remember, if you're left with stuff with x involved when you're taking this integral, then you've done a bad thing. And you need to go back and choose a different u, or you need to recheck your algebra and your derivative over here. We cross the cosines out, and that gives us du over u. And of course, the integral of 1 over u is the same as the integral of 1 over x. It's ln of u plus c. Ln, of course, is sine, or sorry, u, of course, is sine, so my final answer is, whoops, ln of sine of x plus c. All right, moving on, the last two problems. These are some basic u substitution problems. In this case, we want to choose the inside function to be u. The inside function should be x squared plus 1 on this problem. The derivative of that, of course, is 2x. And now we just rearrange, moving the 2x down to the bottom and keeping the dx on the side. Okay, now what? We replace the dx with du over 2x, and we replace the inside with u. That gives me this. And again, we're happy to see that this x and that x are going to cancel out with each other, and leaving me with just that 1/2, which I can pull out front, u cubed du. Okay, pretty good. What's the integral of u cubed? That's u to the 4th divided by 4, or 1/4 u to the 4th. Of course, my plus c needs to be there. And 1/2 times 1/4 is 1/8. I can replace the u with the original function to give me my final answer. 1/8 x squared plus 1, the quantity to the 4th, plus c. All right, last one, an easier one, right? In this case, the inside function is pretty obviously 9x plus 4, because that's inside the e to the something function. So I take the derivative of that and get 9, and rearrange to get du over 9 equals dx. I replace the dx with du over 9. I replace the 9x plus 4th with u. Okay, and then I can pull that 1/9 right out front. And of course, the integral of e to the u is just e to the u. That's a really interesting property of e, right? E to the x, its integral and its derivative is itself, which is a really interesting function. And of course, we just replace that u with 9x to the 4th. And don't forget about your plus c. So that does it for reviewing the quiz. The next thing you should do is complete the extra problem sheet, which Ms. Heil is going to have for you. And the answers are included on that sheet. And then you should go back and see which things you stink at the most. And if you want, rewatch the old lectures on topics that you're weak on. I want to say it's been a little while since we practiced some of those rules for integrals. Remember we had that legit or not legit sheet. You might want to review those, because those are going to be on the quest that you're going to take tomorrow or on Tuesday if you're on JSA. There's also some additional practice videos that you can watch that I used to do with my Smart Pen, that you can watch all this and study, because I want to see some really top grades on the exam tomorrow or on Tuesday. All of the stuff that you need is available on mrcaden.com/apcalc, so you're not going to just waste the rest of this period, and you're not going to waste tonight while you're studying. You're going to go and watch some of this information and get yourself an A on the quest tomorrow. Good luck.